We are beginning Chapter 9 on hypothesis testing, which is an art of decision making. In Section 9.1, we're going to talk about the basic principles of hypothesis testing. So we're going to start with defining a null and alternative hypothesis and how to set them up, the purpose of a hypothesis test, and we're going to state the conclusion to hypothesis test and distinguish between type 1 and type 2 errors. Objective 1, we're going to define the null and alternative hypothesis. A study published in the Journal of Air and Waste Management Association reported that the mean amount of particulate matter produced by cars and light trucks in an urban setting is 35 milligrams of particulate matter per mile of travel. Suppose that a new engine design is proposed that it is intended to reduce the amount of PM in the air. There are two possible outcomes that could happen with the new engine design. Either the new design will reduce the level of PM, or it will not. These possibilities are called hypotheses. One of the hypotheses is called the null hypothesis. The null hypothesis is typically the initial conditions of the population. The other is called the alternative hypothesis. Based on some treatment effect or some improvement in a product, we want to find out whether the alternative hypothesis is true. The null hypothesis about a parameter states the parameter is equal to a specified value mu naught. The null hypothesis is denoted as H naught, which then shows that mu is equal to mu naught. This is the initial condition for the population. The alternative hypothesis is about a parameter states that the parameter differs from a value specified by the null hypothesis, mu naught. The alternative hypothesis is denoted H1. There are three possible alternative hypotheses. A left-tailed test, where mu naught is less than mu is less than mu naught, which is H1. A right-tailed test where H1 is such that mu is greater than mu naught. This states that the parameter is greater than the value specified by the null hypothesis. And finally, we have the third option, which is H1, where mu is not equal to mu naught. It differs. So here we state the parameter is not equal to the value specified by the null hypothesis. Both 1 and 2 are called one-tailed tests, and we will see how they work in Chapter 9.2. So for example, boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. State the appropriate null and alternative hypothesis. So, the null hypothesis states there's no difference. That is the initial condition. So we have H naught such that mu is equal to 20. The inspector thinks that the mean weight may be less than 20. So H1 is mu is less than 20. This would be an example of a left-tailed test because H naught is such that mu is less than 20. In example 2, last year the mean monthly rent for an apartment in a certain city was $800. A real estate agent believes that the mean rent is higher this year. State the appropriate null and alternative hypothesis. Well, the solution is that H1, or H naught actually, is mu is equal to $800, right? That's the initial condition, right? Initial condition. of the population of rents. Now, we believe our hypothesis has changed. We believe that the true value of average rents have actually increased. That's what we believe, so we're going to test that hypothesis. So now we're testing the alternative. Here is the alternative hypothesis test. Scores on a standardized test have a mean value of 70. This is our third example. Some modifications are made to the test, and an educator believes that the mean may have changed. State the appropriate null and alternative hypothesis. So a key word here is may have changed based upon the improvement of the test, right? So our initial condition, again, is mu is equal to 70. That's our initial condition, which is our null hypothesis. This is the null hypothesis. And then we have the alternative hypothesis, which it may have changed. We don't know how it's changed, whether it's gone down or whether it's gone up, but it's different from 70. So there's our alternative hypothesis, right? Our alternative, right? So now we want to state why we do hypothesis tests. So the researcher begins his study with a hypothesis statement about the population and the variables of interest. Remember, the variables that we could have are either qualitative or quantitative variables. The hypothesis achieves one of the following possible decisions: a comparison problem, which compares the sample statistic against the population parameter defined. In other words, when we take the sample, we then compare that sample against the population parameter mu. A validity statement compares a claim of a company from a sample of products of the company. So this is what we call the consumer report process, and it's called a validity statement. Finally, in our scientific world, we have theoretical problems which test current conditions of the population against experimental results of the sample, like drug testing. Many times a hypothesis test is like a trial. The process of the hypothesis test is to determine how likely it is that the null hypothesis is true. The idea behind a hypothesis test is similar to a criminal trial. At the beginning of the trial, the defendant is assumed to be innocent. Then the evidence is presented. If the evidence strongly indicates that the defendant is guilty, we abandon the assumption of innocence and conclude that the defendant is guilty. In a hypothesis test, the null hypothesis is like the defendant in a criminal trial. H naught in this particular case is the defendant is innocent. So at the start of the hypothesis, we assume that the null hypothesis is true. Then we look at the evidence which comes in from the data that has been collected. If the data strongly indicates, that's a very important word, strongly indicates that the null hypothesis is false, we abandon our assumption that it is true and believe that the alternative hypothesis instead. This is referring as rejecting the null hypothesis. So again, we assume current conditions. The null hypothesis is true. We look at the evidence, and then we decide whether to reject the null hypothesis. So once we do a hypothesis test, we want to state the conclusion to the hypothesis test. So stating the conclusion, once we've done the hypothesis test, which will either be a z-test or a t-test, we may either reject the null hypothesis or fail to reject the null hypothesis. If the null hypothesis is rejected, the conclusion is straightforward. We conclude that the alternative hypothesis H1 is true. If the null hypothesis is not rejected, we are saying that there is not enough evidence to conclude that the alternative hypothesis H1 is true. We are not saying the null hypothesis is true. We're saying that the null hypothesis might be true. So here's our first example. Boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this, so he performs a test of H0, mu is equal to 20 versus H1, mu is less than 20. He rejects the null hypothesis and states the appropriate conclusion. He only rejects the null hypothesis after he does a certain test. Because the null hypothesis is rejected after the test, we conclude that the alternative hypothesis is true. We conclude that the mean weight of cereal is less than 20 ounces. Now suppose, in example 2, the same conditions hold. The cereal is labeled containing 20 ounces. An inspector thinks that the mean weight may be less than this, so he performs the test of H0 versus H1, and he does not reject the null hypothesis. So he states the appropriate conclusion. Because the null hypothesis is not rejected, we do not have sufficient evidence to conclude that the alternative hypothesis is true. In words, we may state there's not enough evidence to conclude that the mean weight of cereal boxes is less than 20 ounces. Objective 3. We're going to distinguish now between a type 1 and type 2 error. When a hypothesis is conducted and a decision is made, there is a possibility that it is the wrong decision. There are two ways in which a wrong decision may occur with a hypothesis test. If H0 is true, we might mistakenly reject it. This is called a type 1 error, and when it occurs, we reject H0 when it is actually true. If H0 is false, we might mistakenly decide not to reject it. This is called a type 2 error, and it occurs when we do not reject H0 when it is actually false. So when we look at this table here, we can see the decision of H0 is true or H0 is false, and we can go down to see if we reject H0 when H0 is true, it's a type 1 error. If H0 is true and we fail to reject H0, it's a correct decision. If H0 is false and we reject H0, it's a correct decision. If H0 is false and we fail to reject H0, we've committed what's called a type 2 error. In this particular chapters, we'll be minimizing the type 1 error, but we won't be able to minimize the type 2 error. So here are some examples. Example 1. The dean of the business school wants to determine whether the mean starting salary of graduates of her school is greater than $50,000. She will perform a hypothesis test with the following null and alternative hypothesis. H1 is mu is equal to 50,000. H1 is mu is greater than 50,000. Suppose that the true mean mu, 50,000, and the dean rejects H0. Is this a type 1, type 2, or a correct decision? Well, in this particular case, the true mean is 50,000. So H0 is true. Because the dean rejects H0, this is considered a type 1 error. Now suppose we have the same problem, but this time around we have, again, h naught, mu is equal to 50,000. h1 is mu is greater than 50,000, and suppose the true mean is mu is equal to 50,000, and the dean rejects h naught. Is this a type 1 error, a type 2 error, or a correct decision? Well, since the true mean is 55,000, so h naught is false, because the dean rejects h naught, this is a correct decision. So in our third example, we have the same situation. The dean of the business school wants to determine whether the mean starting salary for graduates of her school is greater than 50,000. She performs the hypothesis test of h naught, mu is equal to 50,000, versus h1, which is mu is greater than 50,000. Suppose that the true mean value is mu is equal to 55,000, and the dean does not reject h naught. Is this a type 1, type 2, or a correct decision? Well, since mu is 55,000, h naught is false. Because the dean does not reject h naught, this is considered a type 2 error. This concludes our chapter 9-1. What you should have gotten out of this chapter is know how to write the null and alternative hypothesis, to determine whether a hypothesis test is left-tailed, right-tailed, or two-tailed, how to state the conclusion of a hypothesis test, and how to distinguish between a type 1 and a type 2 error and a correct decision. We will now be talking about, in chapter 9-2, how to perform a hypothesis test using either a z-test or a t-test.